Okay, now reliability is the next section that you have to deal with when you're planning an experiment. So what does reliability mean? Well, reliability means that you can trust something. Okay, so you can trust an experiment. And the way I'd always think of it is in terms of a friend. How do you know that a friend is trustworthy? So let's imagine that you tell a friend a secret, okay, and they keep that secret, right, and they don't tell anybody else. Well, you might think that they're fairly trustworthy, but you wouldn't know for sure because it's just one-off. You know, perhaps they'd forgotten about it and they didn't get a chance to tell anybody. Okay, there could have been something that stopped them from telling people. You just don't know. If you told them another secret a second time and then they went out and blabbed it to somebody, well, then you might be thinking, well, maybe they're not trustworthy. But you have one scenario where they are and one scenario where they aren't. Well, in that second scenario, maybe they might have just forgotten or it just slipped out. You know, that happens sometimes. So, you know, in order to know if they're really trustworthy or not, you would have to tell them another time. And if they kept the secret, then you'd know that they're trustworthy, they're reliable. And if they did it over and over and over and over again, and they only messed up the one time, you would know for sure that they're quite trustworthy. Okay, so that's what it means to be reliable. And it's not much different in an experiment. Like, let's say, for example, I'm doing my experiment. So the experiment that I'm doing is I'm putting a trolley car on top of a ramp, and I'm running that car down the ramp, and I'm timing to see how long it takes to get to the end of the ramp. And then I'm changing the weight to see if a heavier car affects the time that it will take to get down the ramp. Okay? So let's imagine that I was testing one particular weight, like say 100 grams, okay? And the first time I rolled it down, it took 10 seconds. Okay? Now the thing is, I don't know for sure how reliable that is, right? There we go. I may have accidentally put it in the wrong spot. I may have put it, you know, too far up the ramp or too far down the ramp. I may have, you know, something might have been caught on one of the wheels. I may not have had it pointing directly down the ramp. There may have been something affecting its speed. It's going down the ramp. So you know, I don't know for sure if 10 seconds is true or not. Okay? So then let's say that I send it down the ramp again, and I get another time, and it turns out to take 35 seconds. Okay, so that's a bit unrealistic, but you know, it's just for an example. Now, those two times are really, really different. So I know that one of them is incorrect, but that's, you know, I don't know which one for sure. Okay, so I've tested it twice just to make sure the first one is right, and I found, oh, wait a minute, now which one is correct here? So I have to test it a third time. And if I test it a third time and it comes up as 11 seconds, then I'm pretty sure that the 35-second one is incorrect. Okay? And I can just disregard it. I can take it out of my results. I may even want to do it a fourth time just to make sure to get, you know, 3 really good results. But I really only have to do it 3 times, okay? And like I said with that, if you've done it, you know, 3 times and that one there, you know, is looking like it's not correct, you can just get rid of it, okay? Put it in your table of results, but you don't have to do anything with it. I'll explain more about that later on. Okay, so in other words, in reliability, you have to repeat your experiment 3 times. That's standard for any experiment, okay? Right, so that's the first bit. Now the second bit, the independent variable will be changed a certain number of times, okay? Now, the independent variable is the thing in your experiment that you are changing. Okay, so it's the one thing that you've decided to change. Now, if it's numeric, in other words, it's a number. So, for example, in my experiment here, my independent variable is being measured in numbers. 100 grams, 150 grams, 200 grams, 250 grams, so on and so forth, okay? They're all numbers. That means that we need to change it a certain number of times. And the number of times that we change our variable is always 5 times. So in other words, I would have to have 5 different variations of my variable. So 100 grams, 110 grams, 120 grams, 130 grams, and 140 grams. Okay? What that does is it just makes sure that I know that the pattern that I see is going to act the same across a whole range of numbers. If I just did it for 100 grams and 110 grams, I might see a difference, but the difference might have no effect after 110 grams. You know, adding more weight might have no effect at all, and I wouldn't know that unless I tested it. Okay, so that's why we have to change our independent variable 5 times. So the experiment is always repeated 3 times, And the independent variable is always changed 5 times. And that's just for a numeric variable. Okay, and again, if you can't remember, if you're not sure the difference between numeric and categoric variables, there's another video that you can watch on that. Okay, thanks a lot. Talk to you later. Bye.